And hi everyone, my name's Leila. I head up the data science and analytics practice at Digitas. And I'm going to give a quick introduction just to kind of frame things for the kind of meat of today that Divya and Param will run you through. But a topic very close to our heart, I think that, I don't even think arguably is the right word, society has been and is kind of ist and isms, i.e. there's racism, there's kind of ableism, there's sexism, there's so many things. And I think if you think about the world of what we do, we don't necessarily see the direct relationship between how we may be perpetuating those types of things. So if you go to the next slide, please, Divya. I think that we like to think, close the mic thing. I think we like to think that because what we do is based on maths and technology, that we kind of have the luxury of it being free of these biases. So either the bias that we have as individuals, either conscious or unconscious, the blind spots that we potentially have, the limited experiences that we potentially have. And then we also kind of assume that because it's maths and technology, that it's free of kind of these inherent biases. But the reality is everything that we do is built on historical data, and that's how our models learn. And history kind of isn't kind of the best character. And so what we really want to do is, if you go to the next slide, please, Divya, is move away from this idea that we as data practitioners and data scientists cannot, or kind of put our hand up and say, we're not responsible for this, and it doesn't affect us and we don't have control in it. And I think that that's the wrong approach to have. And so what we're really trying to do is use something that we're calling the data science passivity scale and kind of say that I don't think any of us ever intend to actually do harm in the world by what we do and what we're developing. But the reality is if we're not kind of really actionable and targeted and take very strong approaches and activities to not perpetuate kind of the ists and the isms that exist in the historical data and the biases that we either consciously or unconsciously have, we ultimately end up doing harm in the world just by our passivity. And so we really have to take steps to kind of move to a world where we're actively stopping these discriminatory practices in the algorithms that we're developing and the kind of solutions that we're putting into the world. So today what we really want to do is kind of say, look, if there is a passivity scale, we don't think that people are actively doing harm in the world on this call, at least we hope not. But we do probably think that a lot of us are a little bit passive. So what can we do to actively stop those discriminatory practices and then hopefully get us to a world where we're actually creating good with what we're doing, which is, I guess, the ultimate goal of all of us. So with that, I'm going to hand over to Divya and Param that are going to walk you through some examples and some steps about how we actually managed to do that.
Cool. So yeah, thanks, Leila. And I'm going to talk about some of the key types of bias that may creep up in your model. So there's sample bias, which could be when the training data is unrepresentative. So it could be underrepresenting a specific group in the training data set, and that's often in a population data set. It's often the minority groups. There's exclusion bias, where a key variable that could have been important to your model has been left out of the data set completely. So if you were studying population growth and you left out the population size, that would affect your results. There's observer bias, where the experimenter's own biases feed into the study and skew the results. So there could be unconscious biases, which could end up affecting the study. And finally, there's learned bias, which is where the algorithm learns from existing biased behaviors which exist in the data. So let's say you had some text data which had some racist language in it, then your model could learn from these racist behaviors and languages. So as an example, let's say you had trained a model to recognize the key features of these images, but only used data of orange images. And then you tried to classify these objects, which aren't orange. And so unsurprisingly, you would find your accuracy of these classifications to be way off. And so no one would think to use a training data set with only orange images. However, there are many recent instances of blatant biases being introduced by industry-leading experts. In a 2019 study by an MIT Media Labs researcher, Amazon's facial recognition tool was shown to have clear gender and racial biases. And so white men were correctly identified 100% of the time, whereas dark-skinned women were identified to be men 31% of the time. And this tool was being used by some US state police departments to identify criminal suspects. So you can see how this can cause problems. There was an instance of an 18-year-old African-American man who was wrongly arrested multiple times for theft in an Apple store because this algorithm was incorrectly identifying him as a criminal. There's also the example of mortgage algorithms, which are learning from the existing biased behaviors in mortgage lending. And so they were perpetuating these racial behaviors to the point where people of color were finding it harder to be accepted for a mortgage. And so it seems like until governments can develop clear regulation on the use of machine learning and AI, it's up to data scientists to ensure our models don't contain these biases. So going back to the example of Amazon, if the person designing the facial recognition algorithm were in the same majority, which makes up the data sets, i.e. white men, they may not have thought to check whether the algorithm works well for a minority, i.e. dark-skinned women. And so this observer bias would be causing sample bias. The bias would not be detected, so the training data set is not amended to generate good accuracy scores for dark-skinned women, because the overall accuracy score was good. And so finally, we'll think about learned bias. Going back to our orange training data set, who classified our data set? Let's say the orange training data set had been classified by someone who thinks trees and tall buildings look the same. And so every time they saw a skyscraper, they called it a tree. Now your algorithm will think all skyscrapers are trees, which is obviously not good.
Thanks, Divya. Now I'm going to go into some real life examples where you can sort of see this in action, actually have a look at the code in the data sets. So the first one I'm going to look at is this City of LA Kaggle competition. For those of you who aren't familiar with Kaggle, it's a site where different institutions can create a competition. They can put a prize on the competition, it's usually cash, and then they give that to whoever comes up with the best solution. Based on some sort of scoring metric. So an example would be, can you detect all of the landmarks in this set of images? And the winner might be the person who comes up with a model with the highest accuracy score. So this competition in particular, the City of LA one, was set up by the Mayor's Office of LA, as they recognized that the way job bulletins are written can have an adverse effect on the quality of the applicant pool. So they wanted to use text analysis to identify improvements in 3 key areas. And those were identifying language that can negatively bias the pool of candidates, improve the diversity and quality of the applicant pool, and make it easier to identify where promotions are available for certain jobs. The competition was actually one of the first ones I had seen on Kaggle where the winner wasn't decided by some sort of score. Instead, it was based on the quality of the analysis and how well people answered those questions. So it was something that caused a bit of change onto the platform. Next slide, please. So the good thing about Kaggle and their competitions is that you can go in there and you can actually see people's work, especially the winners, and you can understand what they did. So if you go in there and have a look at the notebook of the person who actually won this competition, we've got the link in the slide there, you can see some of his findings. So one area that he focused on in depth was the research around how certain words in job postings can be considered masculine and feminine, and that can have an impact on who's applying for the jobs. That's actually a type of unconscious bias. So his research showed that if you use too many masculine words, it can turn off female applicants. The chart on the left shows the roles that he found had very high levels of male bias. And the written analysis on the right shows that he found that these were particularly high in tech and data-based roles, which I think everyone can sort of understand, right? We know that happens. He also pointed out that since the data has an unconscious bias, when you then start to introduce ML to help you with hiring and recruitment, that bias just carries on into your models. Next slide, please. Another thing that he found was that the use of superlatives can discourage women from applying for roles, as they're less likely to brag about their accomplishments than men. And if you're looking for candidates that have worked at, so-called world-class firms, you're further restricting the pool of candidates that are going to apply. So the graphic at the bottom with the bubbles, they show how gender bias in job postings can change as the seniority increases. And so from right to left, the bubbles get bigger as the position is more senior. And with that, the level of male bias for those roles increases as well. So what I did was I looked at the notebook and the code and some of the research of how he was determining this. And I actually found an old job posting for one of our international offices for a very technical, very senior role. And there was an extremely clear gender bias. The good thing about this stuff being available and accessible to everyone on Kaggle is that you can start to pull some of that code and research and apply that straight away to see if you do have issues within your organization and do something about it. Next slide, please. So this is another Kaggle competition, more of a traditional one based on a score. So for this one, classifying toxic comments, it was set up by Jigsaw, who are a part of Google. And they provided a data set of comments, like the ones you'd see on, on the bottom of a YouTube video. And they had flagged for the presence of different types of hate speech. So homophobia, sexism, racism, other types of identity-based hate. So each record would be the comment, and then if any of those types of hate were present. The task was to then build a model that could identify if an unseen comment had the presence of any hate speech. And I think especially in current times, that's a very useful thing to do because it means that those comments can be removed very quickly. If you go to the next slide. Unfortunately, they had to do a follow-up competition a year later because they found that there were issues with the algorithms that came out of the first competition. So this subsequent competition was looking for unintended bias in toxicity classification. And what they found was happening in reality was that people would make a comment on a platform like YouTube that said, "I'm a gay woman." And the algorithm would tag that as toxic, when obviously that's not a toxic comment. And the reason for that was that the training data set that they had given people were from places where certain identities were overwhelmingly referred to in offensive ways. And so the model had never seen data where the identities were being discussed in a non-toxic way. And so that bias was just fed back to users. And if anything, it just made the problem worse because then those people's speech is now being repressed. And to the next slide, please. And so this paper here, Gender Studies, Intersectional Accuracy, Disparities in Commercial Gender Classification. So this is actually a really important paper and there's a lot of media around it. It's a bit of a landmark paper. So in this study, they looked at 3 commercially available facial recognition and analysis platforms. And they claimed that they could do things like identify someone's gender with extremely high accuracy scores, but it looked like their claims were made on data sets that were predominantly white and male. So these researchers, they got together and they developed a new data set of images, and they consulted a dermatologic surgeon to code these facial images based on Fitzpatrick's scale of skin tones. So they developed this new, more balanced data set that had different skin tones, and it was more balanced when it came to male and female. And then what they did was, since one of the claims of these commercial platforms was to identify gender, they tested that, but on this new balanced data set. And what they found was that for light-skinned men, the error rates were below 1%. but for darker skinned women, the error was as high as 34%, which should be considered unacceptable for something that is being sold to places like, law enforcement agencies. So this highlights that, biases, they can be apparent in the training data set, but they can also be apparent in the data sets used for evaluation. And then that leads to misleading accuracy claims and performance claims. And, up until this point, it seemed like no one was actually questioning that. So next slide, please. So potential solutions. So here's a stat that we found, that in the UK, women represent 47% of the workforce, yet they hold less than 17% of all available tech jobs. So there is a diversity problem. And at this point, can we get the results of the poll? We'll just give that a sec. So yeah, the first question is, do you believe that you work in a diverse team? Okay, wow. Okay, so 44% believe that they do not. And then I think there's a follow-up question to that as well. Okay, it's good to see how many think that it is important. Okay, so if we go to the next slide. So when it comes to trying to fix this, there's no simple or magic answer. It's a difficult and complex space, but there are certain things that you can start to do. So one of the most important ones that I think you can do is attracting diverse talent. Trying to have teams made up of people from different cultures, backgrounds, and experiences. You don't know what you don't know. Everyone's experiences are different. This means that you might not even be thinking about a potential issue in your data set or model, but it might be obvious to someone else, especially if they've got a different background or they were raised in a different way to you. So if you end up with a team of, very like-minded people who all, grew up in the same way and went to similar universities and lived in similar locations, then you're going to miss things. The other thing is keeping a focus on providing the best product and service for your customers. So if your customer base is diverse, your offering should appeal to everyone. It should be as inclusive as possible. If those reasons weren't enough to focus on diversity, there are a number of studies that prove that having a diverse workforce has a positive impact on the team, especially when it comes to productivity, efficiency, and creativity. You should also make sure that you empower people within your team to speak up about potential issues so that they can be addressed early on in the development stage instead of afterwards when your product goes live. And then educating people who work alongside data science teams. Data science shouldn't be a silo. There are other people involved like product managers, delivery managers. And if they start to think about these things as well, then they might be able to offer their opinions and they might spot things that you hadn't spotted, when you were building the solutions. And I think it's back over to you, Divya.
Cool. So from a data standpoint, there's some best practices you can apply to make sure your training data set doesn't lead to biases. So don't blindly use your training data. When you're collecting and tagging data sets, think about what could be a potential cause of bias. So, and if you can't pick up the biases, if you're transparent about what data was used to train your model, then maybe someone else will pick up the bias. So refer back to the different types of biases and see if this could be an issue. For instance, if you're using a UK or US based population source data set, this will lead to sample bias because the minority groups will be underrepresented in the data set. So you'll need to balance your data set to have like equal splits for each group. So some ways to ensure that you'll have balanced data sources are to use multiple data sources to get balanced demographics. So don't just use Twitter, for instance, because there's a skew to a certain age group and a certain gender on the platform. So use multiple data sources and combine them, and try and source human behavior data from different populations, not just UK or US centric. And if you can't source your own balanced data set, then think about generating your own. So we've looked into a platform called Amazon's Mechanical Turks, which is a platform where you can pay people to perform small tasks for a small fee per task. So our emotion detection classifier has low F scores for certain emotions, probably because the training data set had fewer examples of those emotions, but also because these might have been just harder emotions to classify. So what we did was looked into using Mechanical Turks as a way to get people to write tweets for these specific emotions and boost our data set. And this technique can be applied to any kind of bias in your data set. So let's say you had a data set with mostly tweets from men. Using the premium qualifications option on Mechanical Turks, you can specify that you only want opinions from women, and this will balance out your data sets.
And yeah, if we look at other things you can consider, so you know, looking out for research and development. So I mentioned earlier the Kaggle competition around identifying toxic comments, and in that they found that, you know, there was an unintended bias, and that then led to the publishing of this paper, measuring and mitigating unintended bias in text classification, and a new metric called a pinned AUC. So that was released, and then after that, a follow-up to this paper was released as well. So I'd say always keep an eye out on places like the data science subreddit, sites like Towards Data Science, because when new papers get published, someone will usually link them there. Look out for Kaggle competitions, especially the discussion section, to see if people have cited papers that they think are relevant. And then, you know, we've already mentioned this gender shades paper, but it's definitely worth reading that and the media around the paper, because I think it does like a really good job of showing a lot of the issues that are present in, you know, a majority of ML models. Next slide, please. And then the final thing is, I know we've spoken a lot about data sets and how they're generated and how they're used, but one other thing you can also consider is how your models are actually working. I think in this day and age, it's very easy to say, you know, well, the model is a bit of a black box. I'm not 100% sure what it's doing, but it's getting me to a decision. But there are platforms like this one, SHAP, and we've got the GitHub link down below. What things like this do is that they take a model like an XGBoost, like GBM, something like that. You give it the inputs and it tries to map how important and what effect each of those inputs is having in the output of your model. So this helps when it comes to increasing transparency and explaining why your models are coming to certain decisions. And on that GitHub page, you'll find that they've also developed this out to do things like show for image data sets in a neural network, what are the key aspects that are causing something to be classified the way it is. So yeah, just to reiterate, look for research when it comes to data, but also look for research when it comes to models and model transparency. And that's it from me.
Perfect. Thank you guys so much. So let me just, I'll invite everyone to, is that everything from you guys? Have I missed anything?
No, that's it.
Cool, perfect. So I'll invite everyone to turn on their cameras and mics if that works. And I'll give everyone in the audience an opportunity to pop their question into the Q&A bar at the bottom. But while they're doing that, I guess, you know, it'd be good to kind of kick it off from you guys. I mean, what are you guys doing at Digitas to, you know, increase diversity, mitigate bias in your work currently?
I can kick that off. I guess one of the big things for us, and Param kick this off, is the types of people that are doing this kind of work. And it really is about being able to spot potentially where there are blind spots, or understand kind of what to ask of the data, what to ask of the models. And so for us, and I'm not necessarily saying we're perfect, but we really do a lot to ensure that the team is diverse, and we look at diversity on a few different aspects. So for one, all of our job descriptions have a gender bias removal process. So that's kind of run through natural language processing to try and strip out any of the terms that are potentially skewing male. And we do actually have a predominantly female department. The other thing is looking at kind of the types of people that we get into the team, and traditionally, to get into this field, you come from a university track into it somehow, and it could be lots of different ways, like economics, data science, maths. But just that in itself is quite discriminatory. The types of people that can go to university and do go to university is limited. And so we opened up an apprenticeship program last year to bring in people that kind of circumvent needing to go to university. And we were intending on extending that this year to people that hadn't completed their GCSEs, but COVID kind of put a bit of a stop to that one. But we'll be picking that up next year. But there are also things you can do around kind of the types of people that you're interviewing. So, I mean, we all know that you hire like people. It's such a thing. It's that idea that, like, would you hire someone you'd want to get a coffee with or a beer with? And so just acknowledging that that's where people were, and saying, okay, let's have a diverse group of people interviewing people, because that will kind of bring in more diverse people, and celebrating that as well. And I think that this is particularly relevant for us as a community, this idea that you do something, you determine if it's working, if it is great, but how can you improve? If it's not, do better. So, like, we know that there are other kind of axes of diversity that we can do better on. So things around age and kind of those with different types of abilities. So it's never a done process, but I think it's just constantly calling out and constantly evaluating who we are, what we're looking for, where we're sourcing people from, and asking you if that's enough.
Yeah, definitely. That's great. So I'll go just to the start of the Q&A. There aren't many directed, so, you know, if you guys want to jump in, if you want to chat over each other, just let me know. But the first is from Jing, and they've asked, are there any new techniques to develop or measure data set bias?
Yeah, so maybe that one example I showed, that paper about unintended bias in text classification, you know, that introduced a new metric called pinned AUC. So that's a good place to start. I think Google released some new tools recently to measure bias as well. So I think that's based on like TensorFlow and their frameworks. I think that's worth you know, having a look at. It's also good to just like subscribe to different events and things where people are talking about this, because that's usually where new research gets introduced and talked about.
Cool, perfect. And then we've got a question from Zara, which, yeah, is a good point. I think right at the beginning, this is from the beginning of the presentation, but how do you determine what language is racist? Because isn't it subjective? Yeah,
and that's a good point, right? So, you know, in a competition like Kaggle, you know, let's say they give you those YouTube comments, and then they have a column for, you know, racism, one for sexism, you know, one for, you know, transphobia, some stuff like that. The person doing the tagging is already, you know, determining some sort of bias, right? Because it's based on what they class as that, right? So some of the ways to get around that is you define what that means collectively, and therefore the people who are doing the tagging are all on the same page. Other ways I've seen it approached is that you do it by panel. So you might say, you know, to 5 people who are doing the tagging, okay, is this comment racist? And then maybe they use the majority of the 5. So there is no like perfect answer, but those are the 2 most common ways that I've seen it be done. For me personally, I think agreeing the definition first and then doing the tagging is maybe better because it's more transparent. So when that data does get used in a model, everyone's on the same page as to how it was tagged.
I guess also why it's so important to have relevant and recent data as well, and to use fresh data for a lot of the things that we're working on. Cool, so the next question is from Adam. Do you think data bias is particularly bad in the UK versus other places, or is it more of a global issue that we need to work collaboratively on?
It's a good question. I guess it's hard to say. But part of the reason I think it happens, like here and abroad, is that people are too willing to just use a data set they find online and then just make a model out of it and then try to deliver something, right? They don't know how that data was collected. They find it, you know, on some site, and then next thing you know, it's like in a commercial product. So yeah, I don't know if it's any worse internationally, but I think the root cause is quite similar for everyone.
Thank you.
Yeah.
Sorry,
go ahead. No, go.
I was just going to say, this is from a kind of less technical standpoint, but I think if you look at the histories of different societies, that will marry up very closely with the quality of the data and the bias that exists in the data. So based on that alone, it would be just as bad in lots of other countries. And there's kind of a second part of this, which is, does working globally have its own issues? And potentially, yeah, because there's different types of discrimination to different degrees in different countries. And so you really have to look at what those nuances are at a more local level. And you should be doing that anyway with the models that you're building, because kind of what you're optimizing towards is probably markedly different in different locales for lots of different things. So it's probably one of the reasons why this is so hard. It's a really complicated multi-layer thing that you need to crack.
Yeah, and like going back to Param's point, like a lot of people just use the data sets that they find on Kaggle, when like a lot of those data sets have been sourced in the UK and the US. So you'll find people from, you know, some country that's not the UK or the US still using a biased data set. So we need to find more and more sources of balanced data, which don't currently exist.
Yeah, 100%. And I guess on the back of that, I'm just going to jump down to a question by Zara, where she's kind of just made a point. Culture is definitely a factor. I think on average, women are also attracted to different job roles and not the same on average as other men are. So I think that's kind of an interesting comment, really. I think, yes, like I don't know if you guys disagree or agree, but the culture can be changed. And I think that's part of what we're doing, is trying to change the culture. And, you know, especially in tech, a lot of role models need to be changed. You know, maybe they are more diverse, maybe there are more women. And I think that is, you know, building it into schools and building it into young school programs is something that is going to help change the culture. So I think if we stick to just saying, you know, this is how it always is, it will always be that way. So obviously, I don't know what your opinion is on that.
I feel quite strongly, and this is why you discuss it, right? I don't think women are attracted to different jobs, like the task at hand. I don't necessarily think, right, that Param is more interested in data science than Divya. I think that you could make the point perhaps that different environments attract men more than they attract women for lots of different reasons. And I think that goes back to having a culture in a workplace that is open for different genders, different cultures, different experiences, across the axes of kind of diversity. But I disagree that the role is potentially different, but I do agree that the environment that you put that role in is probably a factor that we should be working on.
Yeah, brilliant. Cool, so popping down to Hamad, why do you think some data sources collected data don't realize they've introduced bias unknowingly? Does that make sense to everyone?
Yeah, to be honest, like when someone learns to be a data scientist, maybe they've come from like a maths background, economics background, something like that. Bias is just like a tiny bit of the education, right? Or sometimes it's like it's not even there, right? People are doing courses in like Python, and then they're going to move on to, you know, how to use random forests, and then eventually they'll get onto neural networks and stuff like that. So they're learning the practical aspects of data science, but the whole like ethical part of it just isn't taught, especially considering like how new the subject is, and a lot of people come into it from other disciplines. It can sometimes just be completely missed. Um, so, you know, that's where people, they don't even know to look out for, which is why some of these issues can come up.
Yeah, like if you come from a world where it's predominantly white and predominantly male, you don't realize that like the population is made up of lots of different types of people. Why would you think to look for it in a data set? You wouldn't. So
Perfect. So moving on. So this is from Tatiana. Do you have any particular red flags gained with work experience that raise the suspicion that the data sets you're working with is biased when you see them?
It's such a difficult one. You know, especially because of how diverse data sets can be, you know, tabular versus image data sets versus text. So I don't know, it's a difficult one to answer. I guess if it's something like image data and you're doing something like, you know, object recognition, facial recognition, stuff like that, you know, when you're looking through the data, maybe you can identify things like, you know, are there way more pictures of male faces than female, stuff like that, right? And that could be a red flag. With things like text data, that might be a lot more difficult, just because you could have like a million records of text data, and it's harder to actually extract any bias because you don't know where that data comes from. But it kind of leads to another point, and that's when these data sets get published, I think more needs to be done to say where these are from, right? And how they were collected, and maybe put some of that metadata around it. So if you publish a data set to Kaggle with people's faces, you know, maybe you can put, this is the gender split, this is like a, you know, a racial split or something like that, so that people don't have to then, you know, later on find out that there's an issue.
there's a piece of work actually going on in the US around, could you put, like, you know, with food, how you have a nutritional label on it, can you do that with data sets so that you can see it, which is a great project, which I hope kind of does get off the ground. I know it's specifically focused at research, but it's just as applicable in the world of kind of in the private sector as well, to Param's point, because like you just don't know a lot of the times. And it's quite extensive to kind of go down the exercise of finding out what that is, if you can even find out what it is, what the makeup is.
Yeah, cool, perfect. So next question is from Manny. So when data cleaning transformations take place, there is bias introduced or removed. What would you recommend to either make this known, or can it be done to keep the balance? So any sort of tools or methods that you guys would recommend?
Maybe for that one with the transformation. So let's say you do have a project where you're transforming a data set, and then you're building a model, and then you're publishing that, right? For me, any of the transformations you do, put that in your write-up, right? So if you maybe do have, you know, one of the classes in your data set being underrepresented, and you're doing something like adding synthetic versions of it or something like that, just document all of that, right? And then maybe you run that by someone else in the team, so that, you know, they can give you some steer on, is that the right thing to do? Is that not? But just be as transparent as possible. Because, you know, like with that toxic comment classification competition and the subsequent one about unintended bias, if your data is imbalanced, you need to do something to increase the balance, right? And just getting new data might not be that easy. So you might have to do things like, you know, make synthetic alterations and stuff like that. So an example would be for text data, if you don't have enough let's say, tweets that exhibit happiness, you might run them through Google Translate through 5 different languages and then translate them back. And now you have like a slightly different tweet. But if you're going to do things like that to rebalance your data, you just have to be clear that that's what you're doing, and let it be known when you're building a model as well.
Cool, perfect. And this question just popped up, which I think is really interesting. Sorry, Amy, I'm jumping about a bit, but from Alan, if one is motivated to collect unbiased data, what reference guidelines are available to measure how well that has been achieved?
Again, yeah, it's a really difficult one, right? Because there's no like real hard and fast like rules around this. Like it's just really hard to say. So if it was something like a text data set, then maybe looking at that paper that looked at pinned AUC and helped identify unintended bias in a text data set, you could use something like that. When it comes to something like image data set, I know Divya mentioned, if you did want a data set of images and you use something that represents the population of the UK and the different ethnic, minorities in the percentages that they exist, that would not be balanced, right? You would actually have to rebalance it so your model would consider each group as important as the other. So it's more about finding out how other people have approached this problem in the past than, I guess, looking for like a number or something like that. And I think that's where Kaggle's really good, where if they do have a competition or like a data set that was published where someone has tried to solve that, you can have a look to see what someone has already done and then try to take their workings. And the good thing about Kaggle Notebook is that, people can comment on them. So if it's good, people can say it's good. If it's bad, people can sort of criticize and, offer improvements and stuff like that. So it's actually like a really good environment when it comes to things like that.
Yeah. Sorry, Divya, were you going to say something?
Oh yeah, I was just going to say, I attended a talk where someone from Google was talking about the tools that they have, and they have something called a what if tool, which helps you visualize like different model performance and subsets of the input. So maybe you could visualize subsets of the input, and then you're allowed to visualize them against different fairness metrics, which they've developed. So that might be something to run your data through to check bias.
Perfect. I'm just going to jump down again on the back of kind of that other question. Was a question from Phyllis. It's basically said, should a new department or business area in companies be set up to look into the data bias before using the data? So like using a compliance department, or companies should set up some sort of rules or policy to look into the data before they are being used?
I'm torn on this, right? Because in theory, yes. But then I think one of the issues that we have is that we're taking the responsibility away from the data scientists and the data practitioners and those that are collecting the data. And I worry that if you gave it to an external department, you would be removing that responsibility and kind of creating an extra division and making it even more of a bit of a black box. So I think that it should be everyone's responsibility, and that I think too many end users within companies or within governments of algorithms don't ask any questions and really hide behind the lack of transparency around the data set and what's being built. And so it really should be something that as we evolve and like this is still a very new space. Like if we think that we're on this kind of 75 or 85 year journey to get to true kind of digital, we're not even halfway there. So there's still a long way to go. And I think that we need to ensure that this becomes kind of the responsibility of the data practitioner, but also everyone that ultimately is using it before it becomes kind of consumer facing or in market or dictating the outcome of something. So yeah, it's in theory, yes, but in reality, I don't think we should.
Yeah.
Yeah, I agree. Like it should definitely be the responsibility of the data practitioner, but there should be some sort of government legislation which prevents something like Amazon's recognition tool from being sold to the police department, because there should be regulation which makes sure that the data scientists have to test their algorithms for being fair and stuff before you know, selling it to the government or the police or private companies.
Perfect. So the next question is from Bruce. Are there any most likely non-human based use cases that you've come across where model bias can actually be a good thing?
Yeah, there's like a sort of like fine line between bias and then just something being subject matter specific. So one example would be if you think of all the, you know, the modern transformer models that we use for NLP, they're typically thrown like Wikipedia data and like loads of information about books and stuff, and that's how they learn English, right? And then we use that for classification and for generating text and stuff like that. Now you might get variants of a model like BERT, like CyBERT, where that is only thrown medical data, right? And so its understanding of English is based around medical research, right? While it's a kind of bias because it doesn't understand English in the same way we do, that's a specific subject matter application. And so you're giving it a very specific data set. So yeah, it's not really I think that's where like bias turns into like speciality, if you know what I mean. But otherwise, when it comes to like explicit bias, like, you know, male versus female, I don't have any examples to hand.
Cool, perfect. So moving on, so we've got a question here from David Foster that's been upvoted a few times. He says, great presentation, guys. So thanks very much, David. That's fantastic. Is there a risk of a model being called biased when actually it's just finding true differences between groups? And there's a follow-on, which is, how should data scientists approach this?
Yeah, potentially. Yeah, that's a very good shout. And I think if you've done things to mitigate the bias in the data set, so let's say your two groups, you know, were equally represented in the training data, and then you did find like an actual difference between them, which is, you know, what you intended to do, then that's good. It's if one of those groups had like 1,000, you know, records of training data, and the other had like 9,000. And then you were trying to classify something and it gave you an answer that skewed towards the other. That's where, you know, your finding is actually biased because of the input that you've given it.
Cool. Anyone else? Cool, moving on. Perfect. So we've got another one from, hang on, oh, they're jumping around, everyone's upvoting. From Gus, is it possible to ever fully eliminate bias? And if not, does it then become a question of what is acceptable bias and what is unacceptable bias? How do we define that and how do we decide what that is?
Divya, do you want to take that one, especially with regards to like legislation?
Yeah, I think like in society, maybe it's not possible to fully eliminate bias, but when you're talking about like a machine learning model or an algorithm, which you can continually test and retest for bias, then I think, yeah, we could use machine learning as a way to eliminate bias in processes. So something like the mortgage lending tool was biased because it had like, you know, biased training data, but if we trained it with correct data, then it could actually be used to make mortgage lending like a fairer, unbiased process.
Perfect. And then the next one is from Veronica. What are some ways to minimize bias at feature engineering stage?
So I guess that might be the, you know, it might sound quite obvious, but if you're removing massive bits of your data when you're feature engineering, like you need a good reason why. And again, for me, it just comes down to any of these things that you do, especially when it comes to feature engineering, like don't do it in a silo by yourself, right? Like consult your colleagues, see if you've overlooked something, and document it. It's kind of hard to answer these questions because you know, it can depend on like the actual like problem you're working on, because like feature engineering for text data is very different than, you know, for like image data. But yeah, just try to get other people's opinions on it.
Definitely. I'm going to jump down to, Amy, sorry, I'm jumping again to Jenna Brown's question. Do you think, oh, hang on, where's it gone? There we go. Do you think as more companies digitalize or work from home, this will help or hinder data bias? Should companies create a policy to help define best practice?
I'm not sure if the working from home or working remotely part will make a difference, but Leila, if you want to talk about like the policies around it.
Yeah, I think there's a few aspects. I mean, from a kind of someone that's looking to grow a team, it's quite exciting because it suddenly exposes the roles up to more people. So traditionally, we have lived in a world where, you know, you had to come into an office in London 4 days a week, let's say, and that limits the types of people that are potentially going to be able to kind of come and work in the team. And this breaks down a lot of those barriers. So I think that can be quite exciting. The other flip side of that, though, is we've probably all experienced, you've got to be really active in making sure that you're staying connected with people. And so there is the possibility that you end up being a little bit more isolated, which gets away from what Param's been talking about consulting with your colleagues and things like that. One thing to know, and this is like kind of blowing it out quite a lot, is if we think about all of the data that we leave behind and how that's used to affect decisions based on algorithms that are developed. The thing with being more digitized means that we're leaving more data, which means that more decisions can ultimately be made about what we're doing, why we're doing it, what things we're able to get access to. And so if we aren't able to kind of address these bias issues, it does mean that with this extra data, it does potentially expose more people to algorithms and models that are doing harm. So yeah, it's somewhat good, and then there are also some potential problems with it depending on how you look at it.
Yeah, so I guess on the back of that, I'm going to jump to Kerry's question. This might maybe not be Digitas specific, it might kind of be more open, but the diverse recruit, absolutely. What are any tips to ensure you are representing the people who will be using the products, tools, and platforms, etc.? So those who are having decisions made on them or being profiled, which the data is being used for.
I mean, that is a great question, and one that I also would like to answer. Divya touched on this before about how there needs to be governance and regulation, and I think that you would have all seen it from today's talk. We all have lots of questions, and Param's touched on it as well, how it's not something that when you go through university is really talked about. I think that there is, because at the moment there isn't really a way to have that information. If you think about the GDPR, and underneath that, supposedly you're meant to be able to have access to the data and the decisions that are being made off of it, but there are lots of areas where that's actually not the case. So anything that starts to look into kind of around the justice system or anything like that, that gets around GDPR, so you actually don't have access to that information. So for me, it's really difficult because you have to ensure that we're not doing harm, and that needs to happen at a kind of government perspective. We need to ensure that practitioners aren't willingly kind of creating models that are being sold to organisations that are doing harm. But then on the other side of that, we need to, I think, train and better enable people to know what is happening and what decisions are being made and how to fight that. I mean, we understand what's happening and we work in this issue, and we've all used terms like black box and kind of the need to have the shut solution that Param talked about. Just kind of everyday people that don't work in this area, they need to understand what are the types of things that are happening, and so that they can ask questions and better protect themselves as well. So this is a huge issue that I hope that as time goes on and more people talk about it, and kind of more data scientists talk about it, it will grow beyond just our individual sphere and become something that that has to change, because this is so significant and so problematic, and I unfortunately don't have an answer to it, just that we need to do better, and we need to make this possible.
Perfect. So then I guess we've got probably time for just a few more. This again, probably more of a blue sky thinking, but Alyssa has asked, how can we improve diversity right now if there are still very strong differences in the way people are raised? So the specific example related to gender, again, like we were saying, girls playing with dolls, not exposed to engineering related toys like construction and Lego and stuff like that.
Yeah, it's a tough one, right? I think especially with data science being so new, like, you know, there are people I know who are doing like maybe their GCSEs or their A levels, and when they ask me what do you do, and I say a data scientist, they're like, I've never even heard about that as a job, right? Like they've not even heard the term, or they've only started to hear the term. But then when you tell them about the applications, it's like, oh, that sounds really cool. So I think part of it is like an educational thing, but at a school level, right? Because I think there might be like a misconception or like a stereotype that people who study things like computer science are just trying to be like software engineers, right? Like they sit in like a room looking at a dark screen, like writing code by themselves for some like back-end solution, right? But it doesn't have to be that. Like, you know, you can actually use those skills and make things that, you know, like have a positive impact on the world. So I think it's more about like telling people that you can go down that route, especially if you aren't male, and you can have an impact, and like your participation is needed as well. So for me, yeah, education at an early age is quite important.
100%. Anyone else want to comment on that? No, okay, perfect, cool. So we're kind of at time, guys. So if we didn't get to your question, I will pass it on to the whole team there at Digitas, and you know, we might be able to build something out of it. We might do a survey after, because I think there's a lot in here to cover. In the comments, I know a lot of people were saying there's Alan Turing Institute and Open Data Institute, I think, which Carrie was talking about. There is a lot of resources out there, so we'll see if we can come up with a few, you know, to share with you guys. This video is going to be up on YouTube. Lots of people were asking about it. It will be up there, so it'll be made public, so you guys can check it out when you have a sec. But other than that, thank you guys so much for coming to talk to us today. Leila, Param, Divya. Hope you guys enjoyed it. Yeah? Cool, perfect. So yeah, thank you guys very much. Stay healthy, stay safe, and we will see everybody next Thursday. Thanks, guys.
See ya.